Hey everyone, and welcome back. Today, we're diving into a really cool coding puzzle, the greatest common divisor of strings. This is the second problem in the super popular LeetCode 75 study plan, and trust me, it's a clever one. It takes a classic math idea and flips it on its head for the world of strings. To help us break this down, I've got our usual crew with me. We've got Hanto, who's here to ask the questions we're all thinking. We have Cinzora, our expert guide, who's going to connect all the dots for us. And of course, Mick is here to keep things interesting. Let's get started. Okay, I'll just say it. A greatest common divisor of strings? Seriously, I thought GCD was for numbers. Are we supposed to be doing long division with letters now? I'm a little lost.
That's the perfect place to start, Hanto. It sounds weird, but the logic is actually super elegant once you see it. We'll walk through it step by step. First, we have to figure out what string division even means. Then, we'll hunt for a clue that leads to this amazing aha moment. After that, we'll bring a little math back in to find the final piece, and then see how it all comes together in just a few lines of code.
Right. So, let's tackle that first big question. The problem has a very specific definition for what it means for one string to divide another, and nope, it has nothing to do with arithmetic. In this puzzle, we say a string T divides a string S if you can build S by sticking T to itself over and over again. Think of S as a brick wall, and T is one specific type of Lego brick. If you can build the entire wall using only that one brick, then we say T divides S.
Wait, so you're telling me in this world, A gets to divide AAA? Man, if my old math grades were based on that logic, I would have been a straight A student.
Exactly, Mick. So now that we know the rule, let's look for a pattern. The best way to crack these problems is always to check out the examples they give you. That's usually where the first big clue is hiding.
Okay, let's see. On the left, with ABC, ABC, and ABC, the answer is ABC. That makes sense. Both strings are just made of ABC blocks. But on the right, Leet and code, they've got nothing in common, so the answer is empty. So it seems like for there to be a common divisor, both strings have to be built from the exact same repeating unit.
You got it, Hanto. That is the core observation. So that leads us to the real million-dollar question. If two strings are both just different counts of the same exact building block, what special property will they always share? And this, right here, is what it's all about. This is the aha moment. It's one single, incredibly powerful check that basically solves the whole thing for us. Here it is. If a common divisor string actually exists, then it doesn't matter what order you add the two big strings together. str1 plus str2 will be the exact same thing as str2 plus str1. It's a beautifully simple test. Let's try it out on our good example. ABC plus ABC gives us a string with three ABCs. Now, if we flip it, ABC plus ABC, we get the exact same thing. See? The check passes. And now for the case that doesn't work. Leet plus code gives us LeetCode. But if we do code plus Leet, we get CodeLeet. Totally different. This one's simple check instantly proves that there's no way a common divisor could exist between them.
Ah, I get it. So if two strings are made of the same stuff, they get along no matter who goes first. You could say it's stringmony.
Okay, that's a brilliant trick, Mick. So if string 1 plus string 2 equals string 2 plus string 1, we know a common divisor exists. But the question asks for the greatest one. How do we figure out the length of the longest possible base string? Great question. And this is where we finally bring back some real math. Think about it. If our base string x is repeated to make string 1, then the length of x has to perfectly divide the length of string 1. Same for string 2. So if we want the greatest common divisor string, we should start by finding the greatest possible length it could have.
And that is the connection. We're looking for the greatest common divisor, not of the strings themselves, but of their lengths. The length of our final answer is just the GCD of the length of string 1 and the length of string 2. We just turned this weird string puzzle back into a simple number problem we all know how to solve.
And the best, most efficient way to find the GCD of two numbers is the good old Euclidean algorithm. It's just a clever little loop. You keep taking the remainder of a division and swapping numbers around until one of them becomes 0. The number that's left is your answer. It's super fast.
All right, so we've got our two key ideas. First, the concatenation check tells us if a solution even exists. Second, The GCD of the lengths tells us how long that solution is. Now let's see how this all becomes some seriously clean and simple code.
So step 1 is that critical check. The very first thing the code does is that concatenation test. If string 1 plus string 2 is not the same as string 2 plus string 1, we're done. We stop right there and return an empty string. This one line gets rid of all the impossible cases immediately.
Now, if the strings pass that test, we know a solution is out there. So we move to step 2. We calculate the GCD of the two string lengths. For our ABC example, that's the GCD of 6 and 3, which is 3. This gives us the exact length of our answer.
And finally, step 3. We know a solution exists, and we know exactly how long it is. So all we have to do is grab a piece of one of the original strings, doesn't matter which one, starting from the beginning with that GCD length. And that's it. That's our greatest common divisor string.
And there you have it. What looked like a really confusing string problem is actually solved with one clever trick and a bit of classic math. I think the big takeaway here is how sometimes just changing your perspective, in this case from looking at the strings to looking at their lengths, can make a hard problem surprisingly simple. You know, this whole solution is built on a math concept that's literally thousands of years old, which is pretty amazing. It really makes you wonder, right? What other classic, fundamental ideas are just sitting there, waiting to be the key to solving some modern coding puzzle? Definitely something to think about. We'll be back soon to break down the next problem from the LeetCode 75 series. See you then.